Hi everyone, hope you're doing well. This is a video for day 108, Line of Best Fit day 2. So this is our second and our last day of our Line of Best Fit, and basically kind of puts everything together that we've been doing the past couple days. Correlation, graphing, scatter plots, equations, where to draw the lines, correlation coefficient. Basically everything is in this packet, okay? So last night your homework was the last 3 pages of 107. And that was in yesterday's Edpuzzle. And for tonight, your homework is going to actually be in this packet. It's going to be the last 2 questions, 3 and 4. So definitely make sure that you do those questions and make sure that you put it on Google Classroom so you get credit. Okay, so there'll be no separate video for the homework. It is all in here. All right, so here we go. Make sure you have your calculator. Make sure you have a ruler. And here we go. The table below shows the number of prom tickets sold over a 10-day period. Plot these data points on the coordinate grid below. Use a consistent and appropriate scale. Draw a reasonable line of best fits and write the equation. So this we have to do first before we can get this. All right, so to save time, I actually already put the scale on for you. So just notice that on the regions, this would be blank and you have to do it yourself, but just to save time. All right, so plotting points, this is something that we've done. So remember, this is your X and this is your Y. So we're gonna plot our points. So we have 1, 30, 2, 35, 5, 55, 7, 60, and 10, 70. So that's what we kind of learned on the first day. All right, so now that we have that, we want to do a line of best fit and write its equation. So we have to do the equation first so that I know where to start my line. So this is really the only new thing for today, okay? By the way, you can already tell that this has a strong positive correlation. All right, so let me remind you, to get the equation, this is, you press stat, then number 1, you're gonna put the numbers into L1, L2, and then you're gonna press stat, calc, and then that new number is 4. Okay, so we have stat 1. Remember, you have to put these in L1, you have to put these ones in L2, and they have to go in this specific order because you have to have the corresponding numbers matching. Okay, so we have 1, 2, 5, 7, and 10. And then for the next one, 30, 35, 55, 60, and 70. So just make sure, 1, 2, 5, 7, 10. 30, 35, 55. Okay, so we are good. So then stat calc, remember we're going to 4 today. We're going to 4. So usually we use 1, but the linear regression, which is your line of best fit, is 4. So we go down. Remember, you don't show any work by hand. Everything on the computer, or on the calculator, excuse me, is good enough. All right, so we want to do nearest thousands. Okay, if it doesn't say, you want to write nearest thousands. That's what we all kind of do. Okay, remember A is the slope, B is the y-intercept. So tens, hundreds, thousands, so the 0 does not round. Tens, hundreds, thousands, that 8 does round that up to a 5. All right, so I'll just put my equation right here. Again, this is all from the calculator. So y equals 4.537x plus 27.315. So now, even though it didn't ask for it, I also want you to get in the habit of writing down the correlation coefficients. So tens, hundreds, thousands, so 983. And then I want us to get used to writing a sentence about that. I want you to know about this. Is a very, very, very important number. So this is pretty close to +1, which is your perfect positive. So here is a sentence I want you to write. Okay, I want you to memorize this. So the correlation coefficient shows a strong positive linear relationship. Okay, so far we have the correlation coefficient, remember that's fancy for R, shows strong positive. We know it's strong positive because it's value. And definitely write linear relationship because this is linear, and in the future we're going to show you ones that, I'm going to show you ones that are not linear. And then you want to tell me why. Because the correlation coefficients is close to +1. So this is the sentence that is wanted on the Regents and our whatever test we're going to take. That's what I want you to get used to. So make sure that you definitely have that. All right, so now that we had the calculator do the work for us, you're going to have to go ahead and you have to graph this line. So you need the calculator, or you need the equation, because you need this number right here. You need your y-intercept. Start here. So we learned the other day that in order to draw your line of best fit, you have to just make sure that it's in the middle of the dots. And that doesn't change. But what does change is where you start. You have to start at 27.35. Okay, so you go to approximately where you think 27 is and put your pencil. Now, don't make a dot because you can't have any extra dots. You can only have the number of dots at 1, 2, 3, 4, 5. You can only have 5 dots because that's what you have here. So go to where you think 27 is, and you're going to put your pencil where you think 27 is, and then you're going to use your ruler and try to go in the middle of the dots as possible. So I'm going to go like, I think here. I think that looks good. That gets me like 2 above and 2 below. Okay, so that is good enough. Or 3 below and 2 above. That's good. All right, so now you have your line of best fit. Not only did you follow the correlation, which is positive, but you also started in the position you're supposed to. Okay, so no starting at 0 or anything low or anything high. You have to start right here, and that's why we have to get the equation first. All right, this is a real life example, so I can only have an hour on the right. So no arrow because we have no negative days or tickets. So that's important to know. No negative day, no negative ticket. So that's why you can't have an arrow on the left. And then also don't forget to put your equation on the line. That's really, really important. You don't want to lose a point for that. All right, so that's basically it. What I want to also show you is just a couple more things on the calculator. So remember, if you want to put the equation into y equals, you would press y equals, you'd move over, then you'd press vars stats, then you're going to move over to the equation and press number 1, which is regression equation. And then if you want to graph it, scatter plot, remember just hit zoom. And then number 9, which is zoom stats. So I'm just going to show you that for this first one. I won't for the rest. Okay, so right now we went to calc. We got our equation. Okay, so we're good to go. So now I'm going to put y, and if you press zoom 9 right now, you're just going to see our scatter plot. Okay, you'll see our perfect scatter plot that matches 2 dots, 2 dots, and 1 dot. So I'm going to go to y equals. I'm going to move off of the equal sign. That's what that means. Press vars, which is, don't forget, that's also how you get the variance. Going to go to 5, which is stats. You're going to move over to EQ, put the number 1 regression equation. Regression is just fancy for line of best fit. It puts that into the calculator for you, and press zoom 9 again, and it'll not only graph the dots, but it'll also graph the line, and that's exactly what we have right there. So there you go. All right, so strong positive, we have our notes, calculator, this is the correlation coefficient. Definitely make sure you know that sentence. And all right, let's move to number 2. So for number 2, it says a large industrial plant studies the relationship between the number of hours devoted to safety training and the number of work hours lost due to workplace accidents. Data is shown below. So this is your L1, this is your L2. So I think it's the same thing. We're going to do a scatter plot, line of best fit, the equation. Remember, you have to do the equation first. And then this one does have one extra little thing, and that is your type of correlation. Again, just to save time, I set everything up for you, X, Y. Okay, you have all of your axes are labeled, including your title. You have all the numbers on a consistent scale, so you're good to go. So the first thing we're going to do is we're going to plot all of these points. So go ahead and plot your points. Okay, so we have 10 and 80. We have 19 and 65. We have 30 and 68. 45 and 55. 50 and 35. 65 and 10. And then 80 and 12. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right, so you should have 7 dots that look just like this. And you could definitely tell already that this is going to be a negative correlation because it's a negative. And it's pretty close to a straight line. So when we figure out the correlation coefficient, it should be pretty close to that -1. All right, so now let's plot it. We go to the calculator. Again, this is your L1, this is your L2, this is X, this is Y. So we're going to press stat 1, clear out what you have, and put in the numbers. And then on the other side, 80, 65, 68, 55, 35, 10, and 12. So let's just make sure that we are correct, because it would stink to do all that beautiful work and then get, okay, good. So now I press stat, calc, and 4. Stat calc 4 is going to get us our equation and our correlation coefficient that we're going to write down. So again, we want to do nearest thousands if it doesn't say, which most of the time I don't think it says it. I don't know. All right, so we have tens, hundreds, thousands. So this 2 does not round this up. Tens, hundreds, thousands. The 0 does not round that up. And correlation coefficient, tens, hundreds, thousands. All right, so no rounding for us. So this is all from the calculator. Okay, I'm copying it right from the calculator. -1.062. Don't forget the X. You need the X to tell you which one is the slope. And then for the correlation coefficient, even though it didn't ask for it, we're going to write it down. All right, so before we do anything, I want to go over your sentence for this correlation coefficient. This is definitely something you have to know, so the more we write it, the better we'll get. So the correlation coefficient shows a strong negative, right, because it's close to -1, strong negative linear relationship. Okay, and I have to say the Y. So because the correlation coefficient is close to, and I'll make sure you have a -1 this time, okay? All right, so now that we have that equation, and we want to go ahead and draw our line, remember, we're going to start here, okay? This is where our line has to start. So it's got to start around this 91 mark. And again, don't put a dot there because we can't have an extra dot. We can only have those 7 that we said we have from the beginning. So in the middle, the best of your ability. Let's see, I want to get like 4. That'll give me 3. Okay, I think right here is perfect. It is so much easier too if you kind of have a see-through ruler, because I saw I had 1, 2, 3 or 4, and then 3 above. So about the arrows, no arrows here, and also no arrows here, okay? You can't go here to negative time, so no negative time, and this way would be also time, so no arrow, no negative time. But please make sure you do put that equation on your line. That's important, okay? What else do we have to do? Oh, correlation. All right, so we said before that there is a negative correlation. And make sure that you have your sentence that goes along with it. So it's X versus Y. So X increases, Y decreases. That's what makes it negative. So as the time spent on safety training increases, the work time due to, or the work time lost due to accidents, that's going to decrease. So decreases. All right, so let's make sure we have everything. Everything's labeled. No arrows. We have our equation. We did our negative correlation. We did our equation. We also did the correlation coefficient, even though they didn't ask for it, so we could practice with the sentence. You have to know the sentence for the test anyway. And I think this one looks good. All right, so that's technically the lesson. That's all we really the one I really wanted to go over. So the next two questions are going to be your homework. So 3 and 4 are your homework. Number 5, you don't have to do. You can cross that out. So 3 and 4 are your homework. So if you want to go ahead and do your homework and then come back and check it, that would be great. If not, just go along with me now. All right, so again, we're working with bivariate data. And let's see what we got. Oftentimes, statistical studies are done where data is collected in 2 variables. We already talked about that. Okay, good. A survey was taken of 10 low and high temperatures in Fahrenheit in the month of April. Oh, how perfect. To try to establish a relationship between a day's low temperature and high temperature. So we have our low temperature, that's going to be our L1, and our high temperature, that's going to be our L2. All right, construct a scatter plot of this bivariate data set on the grid below. All right, so this one has a little bit more work because if you notice, I did most of the labeling for you, but I didn't put on any of your titles and on your axes and stuff. So your X is going to be low temperature. So these are important, okay? You always want to make sure everything is labeled. This one is going to be your high temperature. And then don't forget your title. It's always X versus Y. So low temperature, there's that burst, high temperature. All right, so now we're just going to plot our points. So 10 points, go ahead and plot them. So we have 26. Oh, and notice, by the way, I did use the break. The break is what allowed me to skip right to 46. Here, skip right to 20, okay? All right, so 26, 49, 28, and 50, 30, and 57, 32, 54, 34, and 60, 35, and 58, 37, and 64, 38, 66, 41, 63, and then 45 and 72. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alrighty, so this is what it should look like when you're done plotting all of your points. So A is done. Okay, draw a line of best fit and then get the equation. Remember, you have to do the equation first, and we're going to do this all in the calculator. So again, stat 1, move to the top, clear those out, and then copy all those numbers. Whoops. Make sure you press enter after each one. And the second one. And 72. Okay, and then just make sure that you plug them in right. 20, 50, 30, 57, 38, 66, 41, 63, and 45, 72. Okay, good. So stat calc, and then we're going to go down to number 4. And we have our equation, and we have our correlation coefficient. So again, it doesn't say what to round to, so nearest thousands. So tens, hundreds, thousands. So the 6 will round up the 2 to a 3. Tens, hundred, thousands. The 6 will round this up to a 4. And again, I'm going to copy this down. Tens, hundreds, thousands. The 7 will round this up to an 8. So we have y equals 1.163x plus 19.074. Again, we're going to begin our line here. Our correlation coefficient was 0.948. Again, this just tells me how close these dots are to forming a perfect straight line. So I want, again, practice that sentence. So the correlation coefficient shows a strong positive. It's not always strong positive and negative, but most of the time it happens to be. And make sure you have the word linear, because line of best fit and what we're teaching you today, linear regression, has all to do with linear. Okay, tomorrow's lesson will be something different. And then reason why, because the correlation coefficient is close to +1. So definitely make sure you memorize the sentence. You guys are really good at memorizing. All right, so we want to start around 19.07. So that is in our break. So just try your best to, you know, kind of put wherever you think it might be. So this is probably 23. It's a little bit lower. And then just have that line go through the middle of the dots. Let's see. That would be, let's try here. So I have 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay. I think that looks good enough. I think I'm going to go, I think I need to go a little higher. I feel like this is a little more towards those. Okay. Maybe something like this. All right, so just as long as it's somewhere in the middle. Now this is temperature, so because it's temperature, I believe you can have negative temperature. So we're gonna have arrows on both ends. That is okay. And then don't forget to put the equation. Okay. And just remind you can graph this, zoom 9. It might look a little different. Oh no, it kind of looks pretty good. 1, 2, 1, 2, 1, 2. Good. And then while I'm here, I'll just quickly show you, go to y equals, clear this out. Remember, get off the equal sign. Vars, stats, because you're in the stat unit. Move over to equations. Number 1, it puts that equation that we got. And if you press zoom 9 again, it will show you what it should look like. So, oh, see now actually, this is showing that it should be a little higher towards this one. So technically this should be slanted a little bit higher. That's what this is showing. So I guess I could move this a smidge higher. Okay, because remember the calculator is always going to give you perfect. All right, so use your line of best fit. Remember, when it says that, that means you're supposed to be using your equation. Okay, so y equals 1.163x plus 19.074. Sometimes it also means you can actually just physically use the line, so I'll show you that as well. To find the high temperature, so that's y. For when a day in April, again, the low temperature was 42. So low temperature was x. So we're going to put, in place of x, we're going to put our 42. So 42. 9.04. So if you multiply those, you get 1.163 times 42. You get 48.846. And then I add 19.074 to that. And I get 67.92. So that'll be 67.92 degrees. Now, if I actually use my graph, let's see if I'm anywhere close. I'm going to go up. I'm going to go over. So this is 68 and this, oh, nice job. So it's approximately around 67 on the graph. So it didn't help that I did move that line up a little bit according to my graph. So, okay, that was good. So use your line of best fit. Yeah, but usually it will tell you sometimes use the equation or line. I think this one actually you could probably use either the equation or just the line itself, because it doesn't really say equation. All right, D, would you characterize the relationship between low? So this right here, so remember, relationship is just another name for correlation. This is definitely positive. So definitely positive correlation. And again, when it says explain, it just wants that sentence. That's why I always like you practicing the sentence. So for positive, both increase. And tell me your x before your y. So as the low temperature increases, the high temperature increases. And I believe that's true in earth science. I think you guys learned that. But you guys are better than I am and all that stuff. All right, so that is your first homework question. So make sure that you have everything that I have. And then one more question. Again, this is your second homework question. So you're scanning in those 2 last pages for me. All right, so number 4, last homework question. Megan and Bryce open a new store called the Donut Pit. Their goal is to reach a profit of $20,000 in their 18th month of business. The table and scatter plot below represent the profit P in thousands of dollars that they made during the first 12 months. So everything's already drawn for us, so we're skipping that part. So we're going to write the equation, and then we're going to draw our line of estimate. Now we know we have to do our equation first, so we know where to begin. So stat 1, hopefully you guys are getting used to this process. Looks like 1 to 12. All right, and then the y's, 3, 2.5, 4, 5, 6.5, 5.5, 7, 6, 7.5, 7, 9, and 9.5. So stat calc 4. I just realized I didn't check my numbers. Hopefully they're all right. All right, so again, it doesn't say what to round to. So we know we have to do nearest thousands always. Definitely nearest thousands. All right, tens, hundreds, thousands. So that 6 will round that up to a 2. Tens, hundreds, thousands. That 7 will round that up to a 6. And we're going to do our correlation coefficient. That 9 will round that up to a 6. All right, so the equation is y equals 0.572x plus 2.326, right? 2.326, yes. All right, so we have our equation. Oh, I just realized. Notice they're using t for x. Just realized this. And they're using p for y. So this actually is not the correct final equation. So if you did this and you box this answer, that is technically wrong. This has to be p equals 0.572t plus 2.326. So this is really the correct. And again, this is where we're going to begin here. All right, before we do that, I want to quick do the correlation coefficient, 0.946. And I want the sentence. Okay, so the correlation coefficient shows a strong positive linear relationship because the correlation coefficient is close to +1. So make sure you have all that down. All right, so we need to begin here around 2.3. So it's going to be pretty close to the 2. And then you want to make your line as in the middle as possible. So let's see. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. No, that is way off. Okay. Try again. So I got to go a little higher this time. Okay, let's see. We got 1, 2, 3, 4, and 1, 2, 3, 4. Yes, that looks much better. Much better. Okay, so we're going to continue. This line. And we want an arrow on this side, no arrow here, no negative months or money, technically. All right, make sure that you put the correct equation on the line. Make sure you put the one with the P and the T. Okay, the P and the T. What else do we need? This is done. This is done. All right, just this. So using the line of best fit, yeah, so I guess this one you can really do both. You can use the equation or you could do the line. So I guess I'll show both. Using the line of best fit, predict whether Megan and Bryce will reach their goal. So their goal was $20,000 in the 18th month. So in the 18th month, did we get $20,000? No. So no, they will not reach their goal because at 18 months, they will only have made around 13,000, not the 20,000 they need. Okay, and if we were to check that in the equation, So we would put in 18 for t, 2.326. That's going to give us, let's see, 0.572 times 18. And that's 10.296 plus 2.326, 2.326. 12.622 would be 12,622, which is pretty close, right? It's pretty close to what we got. I mean, we got, you know, closer to 13, but that's definitely, we're estimating, remember. So our 12.6 is really close to our 13. But I think, because I'm remembering from yesterday's packet, I believe it'll actually say to use the equation when you have to use the equation. So for your 2 homework questions, 4 and 3, you definitely can just use the actual line, go up and over and interpolate. You actually don't have to use the equation. I think it would say it. So, and by the way, this is 18 months is interpolating, because it's not really inside the plotted values, but it's inside because the fact that you can go up and use your line to get our answer. So we are interpolating. Something like 30 months, you could not use your line. It's not inside this graph. So definitely line of best fit. I think they just allow you to just go up and over to your line. I think it would say equation if they wanted you to actually use the equation. All right, so this was the second day of line of best fit. We did the equation. We figured out how to begin it. You always begin it where the y-intercept is. Equation we got from yesterday, so we already know how to do that. We added on this fancy new sentence for our correlation coefficients. And yeah, that's it. So remember, page 3 and 4 is your homework, so maybe post that. If you have any questions, let me know, and have a great day.